Hello everyone. This is a troubleshooting session for the NSO Developer Days. So my name is Ram Kumar, and I'm part of the post-sales team working with supporting NSO. So today I will present just some basic tips about troubleshooting and debugging NSO when you're developing with NSO. So here I have the 5.3.2 version of NSO, and I'm in the nano services example that's released with NSO. The session is not specifically about nano services, but I just chose that as an example to work with in this session. And you're welcome to stop me anytime, and if you have any questions or if you would like to add anything to what I say. So the things that I wish to cover here are about the logs of NSO, what kind of logs are available and what kind of information is present in each log and so on. And then the output of NCS status, what kind of information you can expect in the NCS status, and some tools that the NCS CLI provides for debugging and troubleshooting. So with that, let's start. So I have already started NSO in this example. And so these are the default set of logs that NSO writes. So let's go through them one by one. So the first one is the audit log. The audit log is the log where all the sessions and it's a general log of auditing where it logs whenever there's a user session created or whenever there is some activity going on in the system. It's logged in the audit log. So here you can see that, for example, someone has created a session using the CLI, and then they have done these commands like packages reload and so on. The audit log is usually concerned with the CLI mostly, but you can also get things like JSON RPC and JSON RPC calls in the audit log as well. And the next one is a developer log. This is quite an important log, both for the user and also especially for support teams to debug the problems with NSO. So here I can just go through the format of the log. In most logs that NSO writes, it will follow the same pattern. Like there will be a log level. It can be info or debug or error or critical and so on. And then followed by a timestamp and the host name from which the log entry is made. And this is usually NCS for NSO. And if it's a conf product, it's conf. And this is the process ID of the Linux or the OS process that NSO is running as. So from this PID, for example, you can know when NSO suddenly restarts. You can find in the logs that the PID will change. And following the PID, you have the subsystem from which the log entry originates. So here it's all, yeah. So here, for example, there is this devel C. It means it's the client API. So whenever there's a new client connecting to NSO from an external package through Java or Python, for example, you will get logs from this subsystem, so to speak. And devel CDB is the subsystem dealing with events related to CDB. CDB is the database used by NSO. And NCS is the sort of the core subsystem that deals with transactions and services and so on. So you can have this kind of separation between the subsystems so that you can know where a log entry is coming from. And finally, it's followed by the actual log message. The developer log is very useful for identifying what is the problem. I mean, especially if you have it in the debug level, you will have all sorts of information regarding failures towards packages and errors from action callbacks and failures due to service related errors, etc. It's always recommended to keep it in debug level for development environment, even though in production it might be okay to have it at info level. Yeah. And then, so the Java VM log and the Python VM log are logs related to the Java and Python implementations. So if you have a package written in Python or in Java, you can expect to have logs related to those in the Java VM log and Python VM log. Let's So you will have the Java VM log even though you don't have any Java packages, because the Java VM is started by default always. I mean, if you don't have any packages, you can expect not to find much information here. But if you do have Java packages, you can find that this Java VM log is quite helpful in dealing with problems related to Java. Similarly, with the Python VM, you can configure the amount of logging and the level of logging in CDB. So we can configure, for example, to log everything about MAPI by setting, let's just show it. So you can do Java VM Java logging logger, and then you can give the package name of the package you're interested in, and then you can set level as level debug. And if you do this, after this, everything that is done over MAPI from Java will be logged in a detailed level in the Java VM log. So this can be very useful, for example, for troubleshooting problems with specific packages or specific nets and so on. Right. And then there's the NCS log or the daemon log. So it logs the normal operations of NSO when it's starting and stopping and so on. For example, whatever the FXS files and init XML files are loaded is logged here. When there's a package reload, it logs which packages are removed and or which namespaces are removed and what new namespaces are loaded and so on. And you can also find that when NSO is stopped, you will find an entry here saying that NSO is stopped by so and so. So this is a log useful for troubleshooting issues with starting and stopping NSO. So when you have some problems with NSO coming up, you can look at this log to see if some specific FXS file or package is the problem, or if there is some specific failure related to XML files and so on. Yeah, and there is this XPath trace log, which you can configure to be enabled in the NCS conf. It logs all the XPath evaluations in your packages like must expressions and when expressions and so on. It's also a very useful log during development, but it's advised not to enable it in production because it's a very verbose log. But in development, it's a very useful log to troubleshoot both performance issues and also uh, problems with related to service packages and your uh, packages where you have some XPath expressions being evaluated. And then there's the error log. Error log is a binary format log that logs whenever there is some error condition or abnormal condition happening in NSO. The internal format is logged in the error log. It's a binary log, and so it's not human readable, but there is a command line option to read it. You can do ncs print log, for example. So I don't have any error entries here currently, so I get it empty. But for example, I prepared an error log from another example. So if you do that there, yeah, so you'll get something like this where you get the internal information about the product, what went wrong. This probably might not make much sense to a service developer, but this is more for the support team. When something bad happens, you collect this error log and send it to the support team for analysis. And as I mentioned, the error log is a wrap log, so it contains multiple files along with some metadata files like index and size. So it's always good to pack up all these files and send them together instead of just sending the first file or only the one of those files and so on. And you can configure how big each of these files can be in the NCSConf. So if you go to the man page for NCSConf, so you can configure the max size of each file here in NCS config logs error log max size. The default is 1 megabyte, and by default there are 5 files. So by default it uses maximum of 5 megabytes, which is nothing. 5 megabytes in disk. So my recommendation is that the error log should be enabled, definitely enabled both in development and in production, because if it's not enabled and something bad happens, we might not have enough to debug what is the cause. So this is one log that I think should be enabled everywhere, no matter what, because it's not very expensive to have it enabled, and there's no point not having it enabled. Yeah, so that's what I had about logs. Any questions until now? Okay. So the next tool I wanted to talk about was the NCS status. So there's a -- status switch for the NCS command that you can use to get the current status of the running NSO instance. Let's just look at what information is available there. So in the starting, you have the version and some internal info about the Erlang VM. And then there's the status, which is started now, but it can also be in phase 0 or phase 1, for example, when it's in the process of starting up. And then there's a list of namespaces where all the namespaces that are loaded into NSO is listed, along with the agents to which it is exported. So here all means that it's exported to all the agents. And here, for example, it's this namespace is exported only to the SNMP agent. So yeah, this follows. This is followed by the actual Yang models, where you get the module name and the revision and the namespace and prefix, and also the exported agents for all the modules that are loaded. Then this is followed by the section about mount ID. So this is new in CDM. This means that for each NED you load in NSO, there will be a mount ID defined. So it will here this you will get a list of all the available mount IDs, which means that if you have multiple NEDs of the or multiple versions of the same NED, you will have multiple different mount IDs for each of them. You'll have the same modules but in a different mount ID. So here you can see which versions of the NED are loaded and what mount IDs they are under. And here there's a list of loaded packages with the status. Here also you can see if there is anything wrong with the packages that are currently loaded. You can get this information from the NCS CLI as well by doing show packages, for example. But it's also available in the status, and this NCS status is probably an easier way to get it without going into the CLI. So I just wanted to show what will happen here if you have some problem. For example, in the link package, let's make a small mistake in the package and reload the packages. So in the template, so the link is a service package. In the example, it doesn't matter what it actually does. So let's just say there is some garbage in the template file. So let's go to the CLI and reload the packages. And yeah, of course, you get an alarm here with the error message. But let's say that you start NSO with this package, and then NSO has started fully, and now you don't know the status of the package. You can do NCS status, and then you'll get the same error here as well. So this is a quite useful section to get an overview of the loaded packages and what status they are in. And then that is followed by the active user sessions. Currently there is no active user session, so it's empty. But then that's followed by the system sessions, so-called so system sessions are sessions that are not restricted by access control rules. So they are typically created over the MAPI interface via packages. They are also used heavily by NSO internally. So you can see that there are a lot of system sessions being active here. So this one, for example, looks like it's the session started by the Java VM. Yeah, so you can expect this kind of system sessions always, because there are lots and lots of system sessions being used internally more and more. So the system sessions is followed by a list of call points. So a call point is when you have a Yang model where the data is provided by an external data provider. So in the call points list, you can get the ID of the call point and the ID and the name of the daemon. This is the name and ID that you give when you start the daemon via the C or Python API, for example. And more importantly, it lists the exact callbacks that the daemon has registered. This can be used to get a quick overview of what callbacks are available for which daemon or which call point. And the same for validation points and action points. And the same for service points. So here it says that link service point is not registered because we deliberately made a mistake to make the package fail to load, right? So let's correct that mistake quickly and see. Okay, so now it's loaded, and if you do, yeah. So now we have this link service point registered with these component and states. So components and states are specific to nano services. So even if you ignore these callbacks are registered for this service point. Yeah, so I think this is quite useful for nano services, especially when you have a lot of components and a lot of states, and each state may have its own callback. So you can get an overview of which states are available and what callbacks are registered for those states and so on. And then it's followed by type points. It's probably not much relevant for regular developers, but if you register your own type point for handling a custom type, it will show up here. As you can see, NSO uses several type points for its own internal use. And then you get some information about some notification streams and whether you have registered any authentication and authorization callbacks, error formatting callbacks, and so on. And finally, you get a section about CDB, where you can get the file size of the CDB files and the amount of memory it's occupying in the RAM currently, and whether there is any lock set on the CDB currently. And if there is a lock set, you will also find which session is holding that lock here. Yeah. So these are the information found in NCS status. It's quite a handy tool. So aside from using it for your own debugging purposes, it's always good to include the NCS status output when you create a support case towards us, for example. So we can say exactly the current status of the NSO. And then the next tool I wanted to discuss was the Debug Dump. So Debug Dump is a tool to capture the full current state of the running NSO instance. So you can get that by doing ncs debug dump with a file name. So then NSO will take a snapshot of the current state of its internals and write it to the file. It's also a binary file, not human readable, but you can use the show debug dump flag to NSO to actually show it. It has a lot of information about not only about the NSO internals, but also about the system in general, like amount of free memory and the top output of the processes in the OS and so on. Some of that info might be useful for normal debugging, but the actual internal state might be useful for the support teams to deal with if there is any problem. So it's also good to provide a debug dump when you create support cases. Normally, support engineers might ask for a debug dump in a specific point in time, depending on your problem. And it might be easier or difficult, again, depending on your problem, to get the debug dump at that particular time. But just knowing that this tool exists to get a snapshot of the running system is useful. Then all this is sort of wrapped by a script called NCS collect tech report. So it comes with every release of NSO, and it's originally intended for use in a system install. But I think you can make it work in a local install as well with some hackery. So if you look at how it is implemented, it uses this install dir option to locate where NSO is installed. And in a system install, when NSO is installed, it usually writes this install dirs file that specifies where is the config dir and run dir and log dir and so on. So if you want to use this in a local install, what you can do is to set these environment variables yourself and call the collect tech report script. That should work to get a backup of your system even if it's a local install. Although if it's a local install, it's probably easier to just copy the whole runtime. But for system install, this will collect the whole tech report with a debug dump and the CDB files, packages, and everything that's needed for troubleshooting or debugging. Yeah, so those are the tools that I wanted to discuss. And finally, I would like to show something in the CLI. So there are a lot of tools that NSO provides from the CLI to make the life of a developer easier and more productive. One example is the pipe commands. So let's say you do a sync from for the devices, and then you can pipe that to the details pipe command, and then there's some options here like debug and verbose and so on. So if you do very verbose, it gives a running log of what it is doing. So if you see here, it's trying to sync from for these devices, and for each of them it takes the device log, and then you get how much time is spent in each phase and so on. So it's a kind of a progress trace on the transactions, and you get the amount of time spent in each of them, which phase is currently being executed, and so on. So this is a very useful pipe command for seeing what's going on in a particular transaction, and this can be used in an action and for in commit or commit dry run and so on, or redeploy. It's an action. So yeah, it can be used in any place you invoke an action or commit. And there are other pipe commands, for example. So let's create a service here. So as I said, this is the nano service example, and there is a service called link. Yeah. So this is the config you're trying to commit, and let's do a commit dry run. So here it shows that this is what is being committed, or this is what will be committed if you do a commit. But now let's do, so there is a debug command that has these options. So when you use the debug command, it will show additional debug info on those specific things. So for example, if you do a debug template, you can specify the name of the template which you want to debug, especially if you have a service where there are a lot of templates. You can specify only one template if you're worried that only one particular template might be a problem. Or you can just do, let's do a dry run again. If you don't specify any template name, it will be applying for all templates in there. So here you can see what exactly is being done on the template. So you can see that that's the for each instruction, and it evaluates those template expressions as it goes along. There's a lot of info that can be done. So you can specify the name of a template. In this case, there's only one template in the service, but in case if there are multiple templates, you can specify the name of the specific one you're interested in. Another flag is debug service. This will show you what is being done in the service from a fastmap perspective. So if you do a shared set on something, it will show you that this path is being shared set, or this path is being shared created, or so on. But more importantly, it will warn you when you do a normal set or a normal create, because in services, it's recommended that you use the shared version of the set and create and so on to make it possible to be shared with multiple services. I mean, it's okay to do a normal set or create as long as you know what you're doing. But then if you are doing it inadvertently, this debug service flag will warn you what is being done in a non-shared way. And it will also show you exactly what is being done to the service mapping. And then there is another flag called debug kicker. In this case, especially with nano services, but also with reactive services, for example, kickers are being used. In nano services, kickers are used very heavily. So you can see if there are any problems with the kicker by using the debug kicker flag. And whenever there is a kicker config being changed, or when a kicker is being triggered, you will have some debug output on what changed and what kicker is being invoked and so on. And as I said, this is not specific to nano services or services in general. You can commit anything, and if a kicker is triggered by that commit, you can still use debug kicker. Yeah, so debug XPath will show what XPath is being evaluated when the commit is happening, or when the action is being executed and so on. So, but the nice thing about this is that these can be combined. So you can do debug template and debug service and debug kicker, debug XPath, everything, and with details as well. Of course, it will give you loads and loads of info, but it's possible. So you can get this output and go through it to see exactly what happens when you run an action or when you do a commit. But the bad thing with respect to reactive services and nano services is that these pipes will only apply for the first commit, and in reactive services and nano services, you usually have more than one transaction. So if you want to get this debug output for all stages, you have to sort of stop the service in the middle and do it again by a redeploy manually and so on. Or depending on your purpose of debugging, if you get stuck in one particular stage, you can get the service up to that stage and then do a redeploy at that stage with these flags. Yeah, so that's what I wanted to talk about. Do you have any questions or thoughts?
Thank you, Rama. There were some of these that I haven't seen before. Interesting.
Which one was that? Okay. Thank you for joining and thank you for your time.
Thank you, Ram.
Thank you.
Thank you.
Thank you.